Okay, so finishing up what Brianna is saying, there's a combination of both a real number and an imaginary number, and that is exactly right. Very good. All right, you guys, I know the suspense is killing you. Hardly wait based on your responses of not knowing what imaginary numbers. So let us begin. Our objective is to understand the concept of an imaginary number so that next time when I ask you guys, maybe your ticket out, you won't be saying, I don't know anything, because you'll know something. And then we are actually going to be simplifying some radicals because sometimes when we simplify radicals, we end up with solutions. So we really can't work with quadratics and the quadratic formula unless you actually understand what these are. So we have been able to avoid it so far, but no more. We need to address them. Also, for all of you guys, because you are not, well, kinda, I know, but next week is TCAP week, so there is no new word ready. But make sure you use the week to catch up if needed because this is week 8 and there's only 9 weeks of material. You are almost done. But you have a free week next week to really get down to it, get your work done, be productive. You can send me a message like that. Just know that during the day, I may not be able to respond to you right away, but because I have to proctor the TCAP. All right, and then same as always, you guys, always look at Schoology, check your grades, look at your assignments. If you see anything with a U, go back in, click on it, read my feedback, redo it if you need to. But then check in Infinite Campus to see your real grade. And if you go to Infinite Campus, a lot of students just click on grades. But if you click on schedule and you go to core 3, you'll see all the detail of all your work. So you can see all the work you've done, where there might be holes or where you are. It's a really good summary, and so it's actually very nice. So definitely go check that out, you guys. So in Infinite Campus, go to schedule to check your grades. Okay, so let us begin. Okay, so to introduce complex numbers, I have to ask you guys, how would you solve x squared equals -1? How would you do that? You probably do not know, right? So I want you to kind of think, what number can you square and get a negative result? So let me know, you guys, is there any number that you can square and get a negative result? Put what you think. So Brianna has answered. Miriam, Emma, Elliot, what do you guys think? Is there any number that you can square and get a negative result? Emma, that's good, you're honest. That's all I want is your honesty. Very nice, yes. Elliot is racing. Brianna is typing. Miriam, I don't know. Okay, good. And so Brianna said a perfect square like 16, the square roots are 4 and -4. Okay, so that's a little bit different though, because the answer is -4 when you're taking the square root of 16, but that's outside of the radical. I mean, that's actually very thoughtful. I've never had anybody come up with that before, but that was actually really thoughtful. A little bit different though because, and I'm going to write why here as soon as I find my pen tool. If I have, so you said -4, right? If I have the square root of -4, that is different than negative and then square root 4. So if you think about taking the square root of 16, right? So if you're going to take the square root of 16, that's really equal to plus and minus on the outside of the radical of whatever the square root of 16 is. So it's really not a negative in there. But that actually was really, really thoughtful. Very thoughtful. Like I said, I've never had anybody even think about that. So very nice job. So you guys are looking at me thinking, Miss Elliott's crazy. There is no number. What is she talking about? And you're right. There is no number, right? Because what if I did this? What if I did -2 and I squared it? Remember, you have to put it in parentheses. Well, -2 times -2 is +4. That does not work. If I just tried 2 and squared it, well, that's still equal to +4. So essentially whenever you're squaring a number, you're always going to get a positive. So you cannot square any number and get a negative result. And that is why we have imaginary numbers, because of that. So if you think of it kind of like this, a long time ago, back in caveman days or something, and people they traded cows or, lions or something, and they were making their trades. Well, maybe somebody didn't really have any left, but they were expecting some. Maybe some of their, I don't know, their people were out hunting and they were going to get some, but they needed food. So maybe they would trade food for and owe them. Well, we needed some way to represent what it looked like to owe somebody something, right? It's like when your bank account goes below zero. Hopefully that doesn't happen. But if it goes below zero, you have a negative balance. Well, negative numbers are wholly just made up just to explain that type of a thing. And that's what imaginary numbers are. It's basically they're made up to explain how to take the square root of a negative number. Because if you think about math, if we didn't have negative numbers, let's just say, it would be hard to do a lot of calculations. It's the same thing with imaginary numbers. If we didn't have imaginary numbers, we would be foiled at x squared equals -1, right? We would be like, I don't know what x is, I can't solve it, there's no solution. And there is no real solution, but there's an imaginary solution. So that's what I'm going to tell you guys here. So if we take, I'm going to rewrite this, x squared equals -1, and we take the square root of that, because that's how you would get rid of the squared, right? Then what you end up doing is taking the square root of -1. Well, the square root of x squared is just x. And the square root of a -1, like Brianna said, is going to be equal to plus or minus some number. Well, what we've come up with, not me personally, but the math geniuses of the world, have come up with the square root of -1 is called I, like imaginary number. So anytime you're taking the square root of -1, you can just call that I. So we're going to practice a little bit with that. Now you guys are probably thinking, well, I can understand negative numbers and why those would be useful, but why are imaginary numbers useful? So I have a couple of examples for you guys down here. If you can read them, let me move this down a little bit. So one is actually electricity, and these are the waves, the currents that electricity makes. These are called sinusoidal waves, and they alternate between positive and negative. Well, apparently, if you combine two AC currents, they don't necessarily match properly, like this diagram here, and so it can be really hard to figure out what the new current is after you combine them. So if you use imaginary numbers and real numbers together, and that's, Brianna, also what you were saying in a complex number, then it's a lot easier to do your calculations for electricians. So they do use imaginary numbers, and as I just stated, quadratic equation can also give you results that have imaginary numbers, because oftentimes that quadratic formula, the -b plus or minus the square root of blah, 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 well, sometimes you're going to take the square root of a negative number. And so you want to be able to do that and not just be stopped dead in your tracks. So we are going to practice. Are you guys ready? Are you on board? Raise your hand if you are ready to practice a couple. Raise your hand. You guys know where, very good. Emma has found the hand raiser. This is just make sure you guys are awake. Brianna has found the hand raiser. Very nice. All right, Elliot, do you know where the hand raiser is? Miriam knows. Good. Elliot, it's at the very top of your screen. There's a little, I don't know, little guy that he's kind of going like this. So, do you see him? Elliot. Hello, Elliot. Elliot, are you still with us? Elliot may not be with us anymore. Are you fixing your ponytail? All right, well, we're going to move on. I'm just going to assume something is wrong with Elliot at this moment. He's in another location. Okay, so we are going to practice. So first things first, we want to make sure that you guys are good simplifying a radical. So I just want to see if you guys can do this on 12. So what I want you to do is take the square root of 12 which means pull out any perfect squares and leave the rest inside the radical. I just want to see if you guys can do that. So in your notepad, see if you can simplify with just that radical square root 12. And if you don't know, just write I don't know, and that would be fine. And for square root, because you guys are in your notepads, you can just write, like, I'm just going to make up this answer. You could write 5, and then you could type square root 6 or something like that. You haven't seen that either. Okay. Okay, good. So Brianna's got 3 square root of 4. So you're on the right track, but not quite. So let's actually, I'll look at this. This is good. We're going to do this together. So the way we simplify a radical, because you guys know you can't take the square root. Otherwise, you'd all, if it was 4, you'd all say, oh, it's plus or minus 2. Well, the way we do this, there's a couple ways. One way, and you guys pick the way that's easiest for you, is just to break this into 2 radicals. So one of them has to be something that's a perfect square, like 4 is a perfect square, 16 is a perfect square, 9 is a perfect square, something like that. So if I think about 12, I could break this into 4, square root of 4, times square root of 3. And if I do that, then I can take the square root of 4. Oh, so maybe, Brianna, you did have it. You just wrote it weird. But the square root of 4, we know what that is. The square root of 4 is just 2. Oh, no. Oh, you were thinking something else? Okay. Well, you had the right numbers at least, so that is okay. So the square root of 4 is 2, but we can't take the square root of 3, so we would just leave that. So the answer would be 2 times the square root of 3. That's one way to do it, but sometimes when you get big numbers like 72 down here, it might be hard to think of 2 numbers where one is a perfect square. So another way you guys can do this is you can take the 12 and you can break it into pieces, right? So I can break it into all of its prime factorizations, just like when you're doing GCF. So 12 is 2 times 6, right? So it's 2 times 6, but 6 can be broken apart as well. 6 is 2 times 3, so I can put a 2 here and a 3 here. So essentially what I've done is I've broken apart 12 into 2 times 2 times 3. So I've broken it apart into its prime factorization. Okay. Once you have that, well, we're taking square roots, right? So something times something. And if you look, we have a pair. We have 2 times 2, and that's where that 4 comes from. So I can take this 2 times 2 and pull that out as one of those 2's. And then whatever's left just stays inside the radical. That's another way to do it. Oh, that is the format you were writing? So you were doing the root 4 times root 3? You were multiplying. Oh, 3 times the square root. Okay, so you just, okay, so it was close. You were really close. If you multiplied square root of 3 times square root of 4, then you were right there. You just had to take the square root of 4 is all. So you were like one step away. Oh, you just forgot to do that. Okay. All right, you guys. Well, now you've seen one. See if you can figure out how to simplify root 18 then. See if you can do that. So you guys try that. Either do it whichever way you want. You can break it apart into greatest common factors, and then every 2 that are the same, you can take out one of them. Or you can try to break it into 2 radicals, one being a perfect square. So go ahead and give root 18 a try. See what you guys come up with. So I think you're getting it, Miriam. I think you're getting it. So you guys, I think you're all figuring out that we can just break 18 up into the square root of 9 times the square root of 2, because it looks like Brianna, you got that, and Emma, you got that too, and Miriam, you're on track. So we know that the square root of 9 is just 3, but we can't take the square root of 2, so we have to leave that inside the radical. So when you guys write this, you could just write it like you did. You can do 3 times, and then you can write square root, or you could even do like SR if you want to. You could do 3 square root 2 or something like that, or even R is fine. Good. Very good. Okay. So it seems like you guys like doing it that way, so we're going to keep doing it that way. Okay. Now I'm going to show you this one, you guys, because here's where our imaginary numbers come into play. If we have a -4, in reality, if you guys think of -4, this is really -1 times 4, right? So what is the square root of -1, everybody? Somebody tell me, what is the square root of -1? -1. What did we just find out? And I'll go back if you guys need. Square root of -1. Where did we learn that? Oh, right here. The square root of -1 is, yes, thank you, Emma. Thank you. Very good. It is I. So you guys, right away, that -1 can come outside of the radical as I. And then all we have to do is take the square root of 4. What is the square root of 4, you guys? Square root of 4. 2. Thank you, Brianna, 2. So if we take the square root of 4, we get 2, and then we also have that I out there. So the square root of -4 is just 2I. Pretty good, huh? So think about this, you guys. Anytime you have a negative, you can just pull that out as I and get rid of it. And then you can take the square root of the number as normal. So I want you guys to try these. So try these last two, and then I'm going to show you one final thing before we go. So go ahead and see if you can take the square root of -8. And so you'll have to do it like these on the top, and see if you can take the square root of -72. That's kind of a challenge one, but just do your best. So I'll give you guys a little bit of time to work, and then we'll examine it together. So give it a try. Are you still working? Okay. Oh, very good. Good. And then Miriam, usually that I will not be inside the square root. So when you take the negative out, then that comes out as I, and it's outside the square root, away from the square root. And let's see, Emma. Good. Emma, that's good. And then is there anything left inside? Because you have the square root of 8 is equal to the square root of 4 times the square root of 2. So I'm assuming that you took the square root of 4 and got 2, but what happened to the square root of 2? Where did that go? Yeah, IDK. It just disappeared. Oh, you mean to say confused? Yes, yes. Okay. Oh, the steps. Okay. All right. Well, you guys are making a really good effort. So here's what I'm going to do. It looks like you guys are close. Oh, Brianna, that's good. 2I times the square root of 2. That's the answer, actually. So let's look at how we get there, you guys. Here's the steps. Make it really simple. First things first is get rid of that negative. So we know that negative can come out as I, and then we just have positive in here, right? So my brain hurts. No, it doesn't hurt. It's good. Your brain is getting, stimulated from all this great knowledge. Anyway, so always pull the negative out. Take it out right away as I and be done with it. And then now we just need to take the square root of 8. Well, remember, you guys, that the square root of 8 we can break apart into the square root of 4 times the square root of 2. Well, we can take the square root of 4. That's just 2. But we also have an I out here, right? I'm going to put the I in front, but usually we always put variables in the back. This square root of 2, we can't do anything with that. It has to stay inside the radical, so we would just leave that. So what we have is we pulled out the negative as I, we broke apart the 8 into 4 times 2, and we could take the square root of 4. Oh, good, Emma, good. So the best way to write it is really 2 first, then the I second, and then times the square root of 2. But it doesn't matter. Multiplication can go either way. It's just you'll normally see the variable written second. All right, since you guys are having a hard time, I don't want to confuse you totally. So I'm going to help you with this last one because this is going to be a little bit more difficult. So obviously, you guys, first things first, right? We are going to take out the negative. So I'm going to pull that out as I, and then all I have to do is take the square root of 72. So I don't have to worry about that. Yep, that's good, Brianna. We're going to take the square root of -1 times 72. Perfect. And the -1 will just come out as I. Okay, so if you look at 72, you guys, that is the square root of, and that might be a little bit harder, but I can say that, oh, it's 9 times 8. As long as I have a square root in here, I'm perfectly fine. Well, the square root of 9 is 3. So I might be tempted to say, okay, I'm done. I've got 3 on the outside, and then I have square root of 8 on the inside. But as you guys just saw in the last problem, we can actually take the square root of 8 too. So we can turn the square root of 8 into the square root of 4 times the square root of 2. So we can do it twice, basically. Okay, good, Brianna. You're on track of this here. This is good. And so I should probably let Brianna do it. Square root of 4, yes, times square root of 2. Good, Brianna, good. She's on a roll. Okay, Brianna, what are you going to do next? Move this down a little bit. Good. Exactly right. Take the square root of 9 and 4. So square root of 9 is 3, which then I took and put out front. And then I took my 8 and I broke it into 4 times 2, which you were saying take the square root of 4 now. Square root of 4 is just 2. So then that has to go to the front too. So now I have 2 times 3 times I all in the front. And then all that's left in my radical is this root 2. And then the final step would just be to combine everything that's out front here, and 2 times 3 is 6. So it's 6i times the square root of 2. Good. Exactly, Brianna, exactly. So this can be a little bit confusing if you guys can't come up with that this is 36 times 2. If you end up doing 9 times 8, or you can even do 4 times something, I think goes into it. Actually 4 times 14 or something. Anyway, but if you can't get the biggest radical out of it, then if you do it in steps, you just keep doing the same thing over and over again, and then you'll get to here. Okay, so really, you guys, the goal of this is to help you understand that these negatives can just come out as I, and then to give you a little practice simplifying radicals. And you don't need to do that much in the assignments, but I just wanted to kind of bring it up, you know, before you see it and then don't know how to do it. And one of the lessons has it in there too. Okay, what I want to close with, and we can run through some of these too if we're in the lab if you guys want, or if you want some more practice, just let me know and I can give you a resource for this too. But this is one of your assignments, and I've seen a couple people mess it up a little bit. But what we're supposed to do with this is to factor and then solve it to find the roots, right? Well, you guys factored this pretty well. You're like, oh, difference of squares. So then right away you know to factor it into, actually here, let me change this just a tiny little bit, because it actually has a 4 right here in the problem that you guys have. Let's see, 4. Okay, there. Okay, so anyway, you guys think, oh, difference of squares. So then you factor it into x squared minus 4. And maybe I can write x squared minus 4, and then you factor it into x squared plus 4. But then what I've seen people do from there is they take this and they go, oh, another difference of squares. So then they factor this into x minus 2, x plus 2, and then they forget about this x plus 4 right here, or this x squared plus 4, and they forget about it. And so then they just take all this and solve it to get their zeros. But you guys don't forget about this x squared minus 4. We still have to write this, even though it can't be factored anymore. It's still a factor, right? So you guys know that when you are solving to find the roots, you take each of these and set them equal to 0. So you have x minus 2 equals 0. You have x plus 2 equals 0. And then you have x squared plus 4 equals 0. Up until today, you guys couldn't have solved this last one. So let's go ahead and solve everything. So this one would be positive 2. This one would be negative 2. Okay, you guys, last task for you. See if you can solve this for x. Tell me what you get. And then we'll be done. So give it a try. And as you guys are solving, try to do it in your notepads if you can. Okay, so Emma, when you're moving it over to the other side, and I'll just show you, remember that to move something over, you do the opposite. So you want to subtract 4 from both sides. Okay, so then what you're left with is x squared on the left and negative 4 on the right. Does that help? So yeah, Miriam, on yours too, same thing. You oh, okay, you're gonna take the square root. That's okay, Emma. That is why we're doing this, because this gives a lot of people problems actually. All right, so Miriam, you are very close. Brianna, you're still working, good. So Emma, what you want to think about then is how do you get rid of the squared from this point? Like, what would you do to get rid of that square right there? What math would you do? Because you just need x, right? And we have x squared. So what could you do to turn it into just x? Yes, so are you telling me negative x or something? I don't know what you're saying on that one, Emma. You don't know? Okay. Oh, minus. Oh, minus an x. Okay. Except for think about what we really have. Actually, we have x times x, right? Because you're right, there are two x's, but it's not x plus x. It's x times x. So how do you undo? I mean, you can almost think of it as division, but but we don't really think of that as division because then we get something, we get x's all over the place. So that's okay, Emma, that's okay. I'm gonna help you. I'm going to come to your rescue. Have no fear. Okay. So it looks like Miriam her answer is negative 2, and then Brianna has got positive 2i. Okay. So you're Brianna, you're right there. You just left off one answer. Okay, so now you guys, when you think about a quadratic, it's squared, right? Remember that quadratics, and I'm just going to draw a little image here, are used, and they tend to go through the x-axis twice. So there's always going to be two solutions. And if we happen to get a u that doesn't go through the x-axis twice, it's because it's going through the imaginary axes. So there's still two solutions, they just won't be real. Okay? But anytime we have a squared, we're going to have two roots. Oh, Brown, you're still working? Okay. So what we know that when we find the solution, we have to have two answers, okay? And they could be the same answer twice, and that would look like this. We had a graph and we had a quadratic touch the graph and then come off. Then wherever it touched, let's just say this was at x minus 1 squared, so maybe it was at positive 1. It would be squared because it touched it once and then went off. But typically, though, no matter what, we're still finding two solutions. So I know Brianna's still working, but I think she's on the right track. So let's look at it, though, you guys. So in order to undo a square, so Emma, what you're going to do is take the square root. That's how you undo a square. And remember back, way back to this slide here, 2 slides ago, whenever we take the square root to solve for a variable, we have a plus or a minus, like in the quadratic formula, negative b plus or minus. So on this one here, because we're solving for a variable, we're going to have a plus or minus. So the square root of x squared is just x equals, and then we're going to have plus or minus whatever the square root of negative 4 is. Okay, you guys, remember that the negative automatically comes out as I, right? And then all we have to do is take the square root of 4. So it looks like you guys, Miriam, Brianna, you have found the square root of 4 to be 2. So we would write that as plus or minus 2i. So we have two solutions. One is at positive 2i and one is at negative 2i. So our graph is going to look like this top one where it goes through an imaginary axis at plus and minus 2i. Okay, so just a couple things. Okay, good, Emma, good. Just a couple things for you guys to think about is that when you solve for a squared, you always take the square root. And when there's a negative in there, it shouldn't stop you anymore because you just pull that negative out as an I and then take the square root like you normally would. All right, so Miriam, does that make sense to you? Okay, and Brianna, I know you got the right answer, so I think you're in good shape. All right, you guys, any questions about imaginary numbers or how to get them at all from this slide right here? Wait, let me go back. It's coming up. Any questions about this at all? So Emma, you're a no. Miriam, Brianna, guys, any questions about this at all? We have a small class today, especially since Elliot disappeared. Not yet. Okay. Miriam, how about you? You can, okay, you're good. Okay. All right, you guys. Well, then for your ticket out, what I want you to post in the discussion board then is going to be related to these imaginary numbers. So all I want you to do is just tell me what is an imaginary root, what is it, and how would you get an imaginary root? How would you, come up with it? When would you have one? All right. If there is no more questions, you guys, I'm going to let you go. Remember, next week is TCAP week, so no new work, no webinar next week. Bye, guys.